Chapter 5. What is the center of the universe? The big question? What new scientific theories were proposed by Nicolaus Copernicus, Johannes Kepler, and Galileo Galilei, and how did the Church respond? You've probably seen the sun rise and set many times. You've noticed how it slowly moves across the sky during the day. Well, at least it seems to move. If you've paid attention during science, you know that the sun doesn't orbit Earth. Earth orbits or travels around the sun, as do other planets in our solar system. Earth also spins as it orbits the sun. It's because Earth is spinning that the sun appears to move across the sky every day. But imagine not knowing any of that. Imagine trying to explain the relationship between the Earth and the sun based only on what you could see by looking up at the sky. If you think about it that way, it's easy to understand why people in centuries past arrived at other conclusions. The idea that the Earth is at the center of things is called the geocentric model of the universe. At the beginning of the Reformation, this is what almost everyone in Europe believed to be true. The Catholic Church also supported this geocentric view. But the Reformation was a time when many people were questioning long-held beliefs. Martin Luther and other Protestant reformers were challenging religious beliefs. Scientifically minded reformers were looking hard at the geocentric model of the universe, and they were discovering that it too needed to be challenged. From Earth-centered to sun-centered, Ptolemy and Copernicus. The idea that the Earth was at the center of the universe seems to have had its start in ancient Greece. The Greek philosopher Aristotle wrote about it as early as the 4th century BCE. During the 2nd century CE, a Greek astronomer and mathematician named Claudius Ptolemy expanded on Aristotle's ideas. In fact, the geocentric model is sometimes called the Ptolemaic model. Ptolemy supported Aristotle's view that Earth stood still at the center of the universe, while the sun, moon, and planets all revolved around it. He thought these heavenly bodies were located in different spheres, something like gigantic crystal-clear bubbles, with the bigger spheres around the smaller spheres, and Earth at the very center. For many hundreds of years, people accepted Ptolemy's model of the universe. No one questioned his views. No one, that is, until a Polish astronomer named Nicolaus Copernicus came along. Copernicus was born in 1473 CE in the Polish city of Thorn, now called Torun. In the early 1500s, about the time Martin Luther was forming his religious beliefs, Copernicus was studying the movements of the planets and stars. He made all his observations with the naked eye, because the telescope hadn't been invented. What Copernicus observed happening in the heavens, however, didn't really match Ptolemy's geocentric model. He concluded that Ptolemy and the ancients were wrong. Earth does not sit still at the center of the universe. Instead, Earth and other planets revolve around the sun. Copernicus's findings supported a heliocentric rather than a geocentric view of the universe. Copernicus had made a great discovery, but he did not run out and shout it from the rooftops. In fact, he kept quiet about his work. Why? For one thing, he did not have enough evidence to prove his ideas beyond all doubt. Copernicus may also have feared what would happen to him if he publicly contradicted the Church's beliefs about the nature of the universe and the Earth's place in it. It wasn't until 1543 CE, at the very end of his life, that Copernicus published his findings in a book called On the Revolutions of the Celestial Spheres. According to some accounts, Copernicus was handed the first printed copy of his book while on his deathbed. Once again, the power of printing helped to spread new ideas, this time in the area of science. Initially, Copernicus's heliocentric model did not get much attention or cause much disturbance, but a handful of European astronomers believed that Copernicus was onto something. Greek roots. The word geocentric comes from the Greek words geo, which means the earth, and kentrikos, which means as or of the center. So geocentric means having the earth as the center. Helios is the Greek word for sun, so heliocentric means having the sun as the center. Johannes Kepler. German mathematician and astronomer Johannes Kepler was one of these people. While studying at the University of Tübingen in the 1590s, Kepler's mathematics professor introduced him to Copernicus's heliocentric theory. Being a mathematician, Kepler was able to understand and appreciate Copernicus's observations and calculations. Over the next few years, Kepler pursued his own studies of the night sky, eventually publishing a book, Mysterium Cosmographicum, or the Cosmographic Mystery. In this book, he presented a mathematical model that explained the relative distances of the planets from the Sun based on his and Copernicus's observations. Kepler's book impressed another astronomer, Tycho Brahe. In 1600 CE, Brahe invited Kepler to come to Prague to help him calculate planetary orbits. Within a year, Brahe died, and Kepler took over the work. Kepler continued his astronomical observations and eventually formulated theories about the way the different planets orbit the Sun. These theories later came to be called Kepler's laws of planetary motion. Most of Kepler's contemporaries had not changed their thinking, which is why Kepler was so excited when he learned about the discoveries of Italian astronomer Galileo Galilei. Galileo and the telescope. Born in Pisa, Italy in 1564 CE, Galileo Galilei, many people refer to him just by his first name, Galileo, started his career thinking he might become a doctor. At the age of 17, Galileo headed off to the University of Pisa with that plan in mind. But after only a couple of years, he left medical school to study and then later teach mathematics. Galileo was a brilliant mathematician. He made many calculations and discoveries about how objects move. As a well-educated man, he was very familiar with the writings of Aristotle and Ptolemy and the geocentric model of the universe. But he had also read Copernicus's book. Like Copernicus, however, Galileo recognized that no one had yet found conclusive proof that Earth and the other planets orbited the Sun. At the time, Galileo was more interested in explaining how things worked on Earth rather than out in space. But within a few years, his interest changed thanks to a new invention. In 1608 CE, a Dutch glassmaker named Hans Lippershey constructed one of the first telescopes. Galileo learned about the invention and very quickly improved on the design. Within a year, he was using a telescope to scan the night sky. He saw much that directly contradicted the ideas of Aristotle and Ptolemy. These ancient scholars had believed that all heavenly bodies were perfect, with smooth, unmarked surfaces. But through his telescope, Galileo saw that the moon's surface was rough and uneven, marked with mountains, valleys, and craters. Aristotle and Ptolemy also believed the knowledge of the heavens was complete. In other words, what they could see was what existed. With his telescope, Galileo discovered 4 new moons orbiting Jupiter. In 1610 CE, Galileo published a book, Sidereus Nuncius, or The Starry Messenger, in which he described what he had seen through his telescope. These discoveries clearly contradicted the geocentric model of the universe, and that made quite a few people nervous. Several church scholars went so far as to say that Galileo's findings couldn't possibly be true. Yet as use of the telescope spread, other scientists in other countries, including Kepler, made similar observations of Earth's moon and the moons of Jupiter. Encouraged, Galileo continued to study the night sky with his telescope, making discoveries and writing and speaking about them. Although Galileo was a devout Catholic, he didn't think his findings challenged the Church or the Bible. He thought science and religion answered different questions. He said the purpose of the Bible was to show how one goes to heaven, not how the heavens go. But that's not how the church scholars felt who had spoken out against Galileo earlier. They labeled him a heretic and encouraged priests and monks to condemn him. Soon, much more powerful members of the church began to speak against Galileo as well. Galileo wrote letters and gave speeches in order to defend himself, his findings, and Copernicus's views, but things only got worse. Almost silenced. In 1615 CE, the Inquisition, or the court of the Catholic Church, discussed Galileo and the ideas of Copernicus for over 2 months. The judges, called inquisitors, decided that Copernicus's ideas went against church teachings. They ordered Galileo to stop promoting the idea that the earth moves rather than the sun. Galileo realized that he risked imprisonment or worse if he continued. Keeping quiet was much safer and would also enable him to continue working in private. Galileo decided to keep quiet and did so for several years. However, when a new pope, Urban VIII, came into power, Galileo hoped that this new man with new ideas would listen to him. In 1624 CE, Galileo asked the Pope for permission to write a book that would discuss the ocean tides in relation to the contrasting ideas of Ptolemy and Copernicus. The Pope gave Galileo permission to write the book as long as he treated the ideas of Copernicus as speculation, not as truth. Galileo wrote the book as he wanted to, titling it Dialogue Concerning the Two Chief World Systems. The Inquisition was not pleased. Galileo was summoned to Rome to stand trial and was accused of being a heretic. In order to spare himself punishment and possible execution, Galileo eventually recanted. But astronomers and mathematicians who came after him found more and more evidence that Galileo, Kepler, and Copernicus were correct. Around the middle of the 1700s, the Church began to change its position, acknowledging the huge body of evidence supporting motion of the planets around the sun.